Today I am solving the problems on simply supported beam. This is a simply supported beam having a point loads, and there are the two reactions here. These are the two reactions unknown, RA and RB is unknown. Now the downward force I will consider as a positive and upward I will consider as a negative. Smiling face, sagging I will consider as a positive, hogging I will consider as a negative. Now here we have to find out the reactions here, RA and RB. Therefore I will go for summation of vertical forces is equal to 0. Now this one is nothing but minus RA, as per the condition, minus RA plus 2 plus 5 plus 4 minus RB is equal to 0. Minus RA minus RB is equal to, this entire term has to be brought this side, minus 9 plus 11 minus RA plus, take minus outside, RB minus 11, minus minus get cancelled, and this becomes RA plus RB is equal to 11. Equation 1. Now we have to take the moment about A. Taking moment about A. I am taking the moment about A. That means this end is fixed now. This end is fixed. As a result, now RB is there. The RB is moving upward in this direction. That means it will sag. Therefore I have to consider positive sign. That is RB into distance, total distance. The total distance will be 1.5. Total distance will be 1.5 plus 1.5 plus 1.5 plus 1.5. Now it is moving in this direction. Therefore we call it as sagging. Smiling face, positive. Now here hogging face, bottom, it moves clockwise. If you consider the anti-clockwise as positive, clockwise you can consider as a negative. Minus 4 into distance, that is 1.5 plus 1.5 plus 1.5. Next minus 5 into this distance into 1.5 plus 1.5. Next minus 2 into 1.5 is equal to 0. Therefore RB is equal to 6, and bring the entire term this side, it will be 4 into 4.5 plus 5 into 3 plus 2 into 1.5. RB is equal to 36 divided by 6, you will get 6 kilonewton. This is 2. Put 2 in 1, put 1 in 2. You have to substitute this value in here in equation 1. Then becomes RA plus 6 is equal to 11. Further it becomes RA 11 minus 6 is nothing but 5 kilonewton. Therefore RA will be 5 kilonewton and RB will be 6 kilonewton. We have found the reactions. Now we have to solve the shear force diagram. Shear force force. Now there is a load from the bottom. Therefore you have to consider left and right. SF at B, right side. Now right side it will be 0. Now left side, SFB, left side. The reaction is, as per your direction, it should be minus. I will consider minus 6 because the bottom arrow is there. Minus 6 kilonewton. Minus 6. Now I will go for E. There is a point load acting, therefore right and left. SFB, SFE, right. That is the previous value we have tried. Now SFE, left minus 6 plus 4 minus 2. Next at D, again left and right. SF at D, right, that is previous value, and there is previous value will be minus 2, because minus 6 plus 4 is nothing but minus 2. SF at D, left will be here, left is here, that is minus 2 plus 5 is nothing but 3 kilonewton. 3. Again SFC at right, the previous number 3, now SFC left is here, this is the left, 3 plus 2 5 kilonewton. Now at the A, again there is a load, at A there is a load from the bottom, therefore left and right. Now I will consider as the right first. SFA right is nothing but previous number you have to raise as it is. Now from the left, SFA left, previous value is 5, the bottom value will be minus because the bottom arrow I have considered as a negative, therefore 0. Draw the shear force diagram. I am drawing the shear force diagram. The first, this is SFD, above is positive, bottom is negative. Now first is 0, this is first is 0, next is 5. At the A there are 2 points, 0 and 5. At the C there are 2 points, 5 and 3. 5 and 3. At D again 3 and minus 2. 3 minus 2. At E minus 2 minus 6. Minus 2 minus 6. At B minus 6 and 0. Now complete the diagram. There is no UDL, therefore straight line, bottom straight line, there is no UDL here, bottom straight line, complete out, negative, positive. We have completed the shear force. We are going for the bending moment. I will consider here. First I will consider the bending moment about A. Always if there is a reactions are there on this side, it will be 0. I will calculate the value, bending moment at A. Now as the sagging will be, if you moves anti-clockwise, it will be positive. 6 into total distance. 6 into total distance is nothing but 1.5 plus 1.5 plus 1.5 plus 1.5. Next 4. Now it is clockwise. Clockwise is nothing but minus 4 into distance. That is 1.5 plus 1.5 plus 1.5. Similarly minus 5 into 1.5 plus 1.5. Next minus 2 into 1.5. If you calculate, the value will be 0. If you calculate, the value will be 0. If you calculate, the value will be 0 here. Similarly, I will go for bending moment at C. Bending moment at C, again anti-clockwise, positive, 6 into distance, 1.5 plus 1.5 plus 1.5 up to here. Now bending moment up to here, this point. Next minus 4 into 1.5 plus 1.5, minus 5 into 1.5. Calculate, value will be 7.5 kilonewton meter. Next at D, BM at D, 6 bottom Anti-clockwise positive, the positive 6 into distance, that is 1.5 plus 1.5. Next minus 4 into 1.5. Answer is 12 kilonewton meter at E. Bm at E, 6 into 1.5, 9 kilonewton meter, and bending moment at B will be 0. Now I am drawing the bending moment. Everything is positive here, therefore above is positive and below will be negative. BMD. First is 0. Next C will be 7.5 kilonewton meter. Second is 12 kilonewton meter. D will be 12 and E will be 9 kilonewton meter and 0. Therefore straight line, because there is no UDL. If it is UDL, then you have to go for parabola. Positive, 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 positive. In this way you have to solve the problem when simply supported beam is provided with the reactions at a point load.